tutorial is going to be about how to create a scatter plot in Google Sheets. So the first thing you need to do is go into your drive and actually start a new Google Sheets. Once you've done that, you can go ahead and enter your data. So you can see here I have two sets of data entered. I went around and I asked some grade 9s how long they spent studying, and then I looked at their final exam mark. Then I went around and asked grade 12s how much time they spent studying, and I looked at their final exam mark. And what I want to do is create a scatter plot that actually compares these two sets of data. Before I can actually create the chart, I have to reorganize my data a little bit in order to make it work well with Google Sheets. This is something that you do not have to do if you're working in Excel, but in order to get Google Sheets to read the data properly, we have to do a few adjustments. So what I'm going to do is just reorganize things a little bit here. So we're going to take these marks and we're just going to shift them over one column. I'm going to move the title up to the top here, and I'm going to call it Final Exam Mark Grade 12. Rename this one to Final Exam Mark Grade 9. Great, so far it looks pretty good. So we have our titles along the top here, and all of our data entered below. I can get rid of this because I don't really need this title anymore, and I can also get rid of these two rows in the middle here. So what I end up having here now is I have my first set of data, which is for the grade 9 students, and my second set of data, which is for the grade 12 students. I have to have it set up in this way in order for Google Sheets to properly create the chart. So I highlight all my data and I go to Insert, Chart. So there's a bunch of recommended graphs right here. We're just going to ignore them. Do not click any of them. Even though there's a scatter plot option here, notice this little box here tells me that it's going to change the way that I selected the data. So I'm just going to ignore all the recommendations. Google is not as smart as it thinks, and it often misrepresents our data. Instead, I'm going to go to Chart Type. Scroll down and click Scatter Plot. So now the scatter plot is set up the way I want it to. In red I have the grade 12 marks, and in blue I have the grade 9 marks. And what I can do is I could just hover over some of these data points just to make sure that they are in the correct place and make sure they match what I have in my table over here. So we'll leave it at that for now. We'll just click Insert. So the first thing that I might want to do is I want to add some titles to these axes. Right now I have no idea what data is shown down here and what data is showing up here. So we're going to go to Axes and vertical axis title, and the name of that title will be Final Exam Mark, and the units for that will be in percentage. So I'll put the units in brackets. There we go. Next thing we want to do is we want to add a horizontal axis title, and we'll call this Study Time, and I measured that in hours. So that already looks much better. Next thing I'm going to check is just to make sure my scales make sense. So my scale for mark should only go up to 100% because I can't have a mark higher than 100%, so that looks pretty good. And the study time is good as well. Notice that Google Sheets automatically adjusts my scale so that my data fills the graph. It didn't try to compact all the data into one little spot, it spreads it out over the entire graph. Next thing I want to do is I want to adjust what my legend says over here. Final Exam Mark Grade 9 isn't the best legend title. All I want it to say here is Grade 9, and all I want it to say here is Grade 12. So where is Google Sheets pulling these titles from? Well, it's pulling the titles from these two cells right here. So if I just change the name of this to Grade 9, we'll say Grade 9 students, and we'll change this to Grade 12 students. Notice that it automatically adjusts my legend for me. Next thing I want to do is the title of the graph. So I'll right click and go into Advanced Edit, and here's the title of my graph here. So the title of your graph should always give an indication of what the data shows and how you measured it. So let's say that for this data I collected it on students who were writing a math test. So what I'm going to say, I'm going to call my chart Yes, it's a very long title, but it's very descriptive. So it says comparison of study time. Let's adjust that. Comparison of study time and final exam mark for grade 9 and 12 math students. So that's pretty good. My title's good to go. I have axes labels. My scale looks good. Next thing I need to do is add a trend line. So the trend line shows what's happening with my data. So to do that, I can scroll down here. And under series, I can edit the data for each set. So the grade 9 students, if I drop down the menu here, I also have the grade 12 students. So what I want to do is I want to say trend line. I want to add a linear trend line. So that's going to be the blue line there. And I want to label it using the equation. Okay, so there it goes. It puts a little equation over in the box over here for me. The color matches the data set, so that's pretty good. Next thing I want to do is I want to do the same thing for the other data set. So we'll go to the grade 12 data set, and we'll make our trend line a linear trend line, and we want to label it with the equation. What I also might do while I'm in here, let's just change these data points to be squares, just so I can see the difference between the rectangles, or between the circles and the squares. Makes it a bit easier to tell the difference between your data. There is a box here to show what's called the R-squared value. This isn't going to be important in grade 9, but the R-squared value actually tells you how close your relationship is to being a perfectly straight line. Obviously these red dots all over the place are not a perfect straight line, and our trend line does the best to represent them as a straight line. So the closer this value down here gets to being 1, the closer our line is to being straight. Not important for grade 9, but if you were curious to know how well does your data fit the trend line, you could look at the R-squared value. So let's just update that, and so far it looks pretty good. What I want to do is just adjust the sizing of things a little bit so that my data is not as crammed. Just going to resize my graph a bit here just so that it fits the window a bit better. Notice that now my equation is formatted a bit better. And there we go, that's it. I have two sets of data. I have a legend that shows what each data set represents. I have a trend line that shows the equation. I have axes titles that include units, and I have a descriptive graph title. Now, one thing to note is how do I interpret this equation? Well, this is just a linear equation, the same way that we talked about y equals mx plus b in math class. So this number in front here would be your slope, and this number in the back is the y-intercept. I realize that these are very big decimal numbers, but that's just because we're working with data that's not perfect. It's not like math class now where we have perfect integers as our slopes. We have these decimals because our data isn't perfect. If we look at these two data sets, let's just interpret them for a minute. The grade 9 data set has a steeper slope than the grade 12 data set. So what does that mean? Well, that means that as the study time increases, the mark on the final exam increases faster for grade 9s. So there's more of a change in your final exam score the longer you study when you're in grade 9 compared to when you're in grade 12. The initial value represents how much would I score on my exam if I didn't study at all. I didn't study for a single second. Well, if I interpret this correctly for grade 12 students, studying for 0 hours means that I would get a score of about 16%, whereas for grade 9 I'd only get about 3%. Both of these are not very ideal situations, but now that my graph is finished, what I need to do is actually figure out how am I going to export this to my computer. So I have two ways that I can do this. The first way is I can just go up to this little arrow at the top and click Save as Image. And that's going to download the graph as a picture, and I can just print that picture out or embed it into my lab report. The other option is if I'm working in Google Docs, I can just open up a new Google Doc, and I can go to the Insert, Chart, and I'm going to select it from a sheet. This is the sheet that contains the graph we just made, so I'll open that up. Notice that it recognizes right away that I have a graph that I've created inside that sheet, so I'll click Insert. This bottom down here is designed to link my graph to the spreadsheet. I'm going to uncheck it for now, but if I left it checked, what would happen is my graph would be linked to the spreadsheet. So if I inserted this graph into my Google Doc, then I went back and I messed around with some of the data, the Google Doc graph will actually change. But I don't want that. I want it to stay the way it is right now, regardless of what I do to the spreadsheet. So I'll uncheck that and click Insert. Now I have my graph here ready to go, and I can just print this Google Doc out or share it with my teacher.